everyone, and welcome back to our 11th episode of Math Past Year Papers on ZNotes Live. I'm your host, Yukan. I'm here with Devandhira, and today we will continue with further math with paper 4.2, or the further stats paper variant 2. And just before we get on, I'd like to make a short announcement. This is the last episode, or the second last episode of our Math Past Year Paper series, where our last episode will be an AMA or a Q&A session. So, if you guys have any questions regarding the series or math or just anything, you guys can go down to our Discord and check out the hashtag MathsAMA channel to post any questions you might have. On to you, David.
All right, so thank you, Yugen. So as Yugen said, we'll be doing the further statistics paper, and trust me, it's going to be quite long. Right, so let's go for the first question. All right, so we have a table here. We have two randomly selected groups of students with similar ranges of abilities take the same examination in different rooms. One group of 140 students take the examination with background music playing. The other group of 210 students takes the examination in silence. Each student is awarded a grade for their performance in the examination, and the numbers from each group gaining each grade are shown in the following table. So you can see from here. So as what they said, the total number of people that has background music is 140, and same thing for silence. Silence has 210. And our objective is that we have to test at the 10% significance level whether grades are awarded are independent of whether background music is playing during the examination. Basically, this is a test for dependency. So when they ask questions for dependency, it's always chi-square test. Especially if they give you a table and dependency, for sure it's chi-square test. No need to doubt about it. So before we start, we have to write our hypothesis, our null and alternative hypothesis. So our null hypothesis is that the grades are independent, while the alternative, the H1, is that they are dependent. So before we start, I wrote down the same exact table as before, except that I added a few things. So I added the total number here, and also down here in the bottom row. So the 140 is just the total number of this when you sum them up. Same thing for 210. Well, these numbers down here are the total number for each column. Agree again?
Mm-hmm.
Right. But 350 is the total number of students there are. So you see that 140 plus 210 is just 350. So this table shows us the observed data. Now we have to look for the expected data. And how do you look for the expected data? So right here, I've already written the entries, 6 of them, of course. Now, how do you get 56.8? Do you know how, Yugen?
No.
No. Okay, so here's how you do it. So you know that the total number for a grade A student is 142, and for BGM is 140, right?
Yep.
So the trick is you have 140 times 142 times 140 divided by the total number of students. And you should be getting 56.8. So same thing if you want to get for B and BGM, instead of using this, you would use 119 times 140 over 350. So you do the same process for each entry here, and these are the numbers that you should be getting. Like that. Right? Agree again? So far, so good?
Yeah.
All right. So now we have the observed and expected table. Now we can find the test statistic. This is where we play the statistics part. So the test statistics will determine our conclusion later. So for a chi-square test, this is our test statistic. It's always the sum of the observed minus the expected squared divided by expected. So example, let's say I have the first entry here. The first entry, let's say. So I have the observed 49 and the expected 56.8. So what I would do is 49 minus 56.8 squared, then divide by 56.8. And then you have to add it with the next one. So you have to add 51 minus 47.6 squared divided by 47.6. And you keep summing them for all the other entries. Agree, Yugan?
Mm-hmm.
But there is another trick. If you simplify this part, if you simplify this part, you would be getting this. This is a much simpler formula you can use. So instead of observe
Devan,
minus expected, observe minus
pop
expected,
up.
they'll be sorry, they'll be really tiring. So there is a bare shortcut. Instead of observe minus expected, you'd have to, you only have to sum the observed squared, divided by expected right here. But at the end, don't forget to minus the total number of sample. In this case, it's 350.
Mm.
That's what the end here means. Right, so let's do that. So I've written the working here with using this formula because it's much easier. So like I said, for the first term, you have 49 squared right here, and then divide by 56. Next one is 51 squared over 47.6, and you just have to add all the entries. But don't forget that we have to minus the total number of students right here.
Mm-hmm.
It's minus 350. And at the end, you should be getting this number, 3.096, da, da, da. So far, so good, you get right here?
Yep. Yeah.
Now, the next thing is we know our test statistic. This is our test statistic. The next thing we need to know is our critical value. So how do you find the critical value? All right, so it says that, sorry. So our critical value, based from the question, it says that we have to test in a 10% significant level, right?
Mm-hmm.
That means we have to look for 0.9 for P, but we also need to know our degrees of freedom.
Mm.
So how do you find the degrees of freedom? Do you know how to do that? You can?
No, I don't.
No. All right, so this is how you do it. Technically by formula. So right here we have 2 rows and 3 columns, right?
Mm-hmm.
So the formula is actually just R minus 1, where R is row, times the
Mm-hmm.
column minus 1. So instead of having 3, you have 2 and 1. So 2
I
times
see.
1 is just 2. So that the degree of freedom is just 2. Or if you want to see it geometrically, I don't know how you say it. Is it geometrically? Just delete the last row and the last column. And you have
Visually.
the number of entries here. That is just 2. Right. So your degree of freedom is 2, and your P is 0.9. So if we take a look at the table here, you would have, so let's see, where to look for it. So this is the degree of freedom, while this is our P, which is 0.9. It was 10%, so it's 0.9 as the P. So that means our critical value is 4.605, which is what I write here. So as you can see that our test statistic is surely less than 4.6, right? 3 is less than 4.
Yeah.
I don't need to prove that. So that means we can conclude that since our test statistic is less than our critical value, there is not enough evidence to reject H0, null hypothesis. Therefore, we have to accept our H0, our null hypothesis, which is that the grades are independent. And that's how you answer it. So remember, you have to write your conclusion after you've done your statistical test and whatever. This is just what's tiring about statistics, honestly. You have to write your hypothesis, you have to write your working, you have to write your conclusion. It's kind of tiring sometimes, but whatever. It's fun. Right, so next question. The times in milliseconds taken by a computer to perform a certain task were recorded on 10 randomly chosen occasions. The times were as follows. So these are the time here. It is claimed that the median time to complete the task is 6.4 milliseconds. So our first question is carry out a Wilcoxon sign rank test at the 5% significance level to test this claim. All right, so let's do that. So first, before we start, we always have to write our hypothesis, our null, and alternative. So our null hypothesis is that the median time is 6.4, while the alternative is just not 6.4. Right. So the next step to how to do Wilcoxon is Wilcoxon sign rank, is that each of our data here, we have to take the difference from
Mm-hmm.
6.4. So for the first one, we have 6.44 minus 6.4. That is just 0.04, right, Yugen? Right, okay, so for the next one, you do the same thing, 6.16 minus 6.4, and you basically do for each
Devan,
entry. Sorry, yeah? Am I lagging? Hello?
Devan, your stream is lagging and your video.
Oh, oh, sorry. Can you hear me?
Your voice is very choppy. All right, we'll be back with you guys shortly.
Can you hear me
Welcome
now?
back, Devan.
Oh,
Yeah,
all
yeah,
right.
you're fine now.
All right. Right.
Sorry about that,
So,
everyone.
okay. Sorry about that too. Right. So, as I was saying, is that when you want to do Wilcoxon, is that for each entry, you have to minus the median. In this case, our assumed median is 6.4. So that means our first one, 6.44, minus 6.4 is just 0.04, right, Yugen? Hello, Yugen?
Mm.
Okay. So same thing for the second one
Yep.
is just
Yeah,
6.16
hello.
minus
Okay.
6.4. Yeah, I can hear you. So you basically do the same process for each entry here, and we write that down. So I've written all of it down here. Actually, it stretches out through the whole page. Now, the next thing you want to do is that you want to rank the difference. So let's say the smallest difference will be rank 1. Example for this. Right? Because as you can see here, 0.02 is the smallest difference, right? Yugen?
Mm-hmm.
So that means I rank it 1. Then the higher it is, the higher the rank. So next one is
Mm-hmm.
0.04. Now the third one is negative 0.06. Now I mark 3 in red because it's negative. You'll see why later. It's part of the Wilcoxon test. So make
Mm-hmm.
sure when you want to do Wilcoxon test, you have to differentiate which one's negative and which one's positive. And yeah, basically you just continue it. Like let's say for the next one is 0.11. That's the fourth one. Then you keep going. Now
Mm.
here's the thing. We let P be the sum of ranks for the positive difference, while Q will be the negative differences. So how do I get P is equal to 14? That'll be 1 plus 4 plus 7 plus 2.
Mm-hmm.
Agree?
Yep.
Yeah, so that's basically 1 plus 7 plus 4 plus 2. Same, but for Q, that'll be for the negative differences. That means I have to add 8 plus 10 plus 9 plus 6 plus 3 plus 5, and you should get 41. Now that we have these two numbers, we have to take the minimum. Well, we call it T. If you look at the table here, sign rank. All right. See, it says that T is the smaller of P and Q. Basically, the minimum of P between P and Q. So in this case, it's
Mm-hmm.
just 14, correct? 14 is smaller than
Yep.
41. Right. So we have T is equal to T is 14, and that's our test statistic. Our test statistic is 14. Now we still have to look for the critical value. So remember, our what do you call it? Our experiment is two-tailed because we want to say it's
Mm-hmm.
either unequal to 6.4 or not equal to 6.4. That's why it's two-tailed. And our sample number of sample is just 10 and is equal to 10. That means if you
Mm.
look for it right here, we know that it's two-tailed. Oh, I forgot to mention that it's 5%. Yeah, it's 5%. That means it's two-tailed, 5%, and it's 10. So the critical value is 8.
Mm-hmm.
Right. All right. So our critical value is 8 here. Right. So here's where it might get confusing is that since our test statistic is greater than 8, we don't reject our null hypothesis. Usually we do, but only in this case we don't. So if you look at the what do you call it, formula sheet, it says, see, the table gives the largest value of t, which will lead the rejection of null hypothesis. So anything higher than that will
Devan?
not get rejected. Agree, Yugen, from the sentence?
Mm-hmm. Yeah, yeah.
All right. So only in this, you can say in this chapter, in this question, where if the test statistic is greater than the critical value, you don't reject the null hypothesis. So that means we accept our null hypothesis, and the median time is 6.4.
Mm-hmm.
All right. So for letter B, it says state an underlying assumption that is made when using a Wilcoxon sign rank test. Now it's just one mark, and you kind of have to memorize this. Is that the data is symmetrically distributed about the median? That's it. That you get the 1 mark from that. Right. So far so good, Yugen?
Yep, that's all right.
Okay. Anything you want to add?
No.
Okay. Right. So
But
let's.
yeah, I
go.
think that just that part with the test being more. Thank you for explaining that.
Okay. You're welcome. Right. So let's go for the next question. The continuous random variable x has probability density function f given by this. Find the e of x. Right. So let's do that. So how do you find e of x? Do you know how to do that, Yugen?
Yeah. You have to multiply the first one by x and then integrate with the limits, and the second one as well, and of course
Exactly.
take the sum.
Exactly. So let's do that. This is actually something that's given in first year undergraduate actuarial science. So if you learn this, it's going to be really useful. So let's do that. So our ex is defined to be like this. Basically, minus infinity to infinity is basically the whole domain of our function. But in this case, our function is just from 0 to 1 and then 1 to 9. So let's do that. So here's my function, of course, and I multiplied by x. But since this function only occurs at 0 and 1, that means I put our boundaries at 0 and 1. Same thing for the other one, but we have to add it. So right here I have the x, and you multiply by this function right here. Since it goes from 1 to 9, our boundaries is also 1 to 9. Right, and we just have to integrate normally. And I think you can do this. Do I have to explain how to integrate? No need, right?
Oh yeah.
All right, so basically you just integrate
No
normally.
need.
You can just expand the x, factor out the 3 over 16, then integrate. Put the boundaries in, and you as your final answer, it should be 269 over 80. Right. So I guess this is quite straightforward. So let's go for the next question. The next question is quite harder. The random variable y is such that y is equal to root x. Find the probability density function of y. Sure. So how do you find the probability density function of y? What's the strategy here, Yugen?
Oh, I always struggled with these kind of questions.
Oh, you always struggle. Okay, I'll show you. So here's by definition. So right here, if I have an f subscript of y, big letter f, this is the cumulative frequency, cumulative distribution function, CDF. You know what that is, right?
Yeah.
Now, by definition, cumulative CDF is basically the probability of y less than smaller y. Basically, any number y here, right? Now, since they give that y is equal to root x, we can simply just substitute y into root x right here, and it's less than y. And we can take the square of both sides, so that we have x is less than y squared. But we know what p of x less than something is. It's basically our CDF in terms of x. Right. So that means if I want to find the PDF of y, PDF of y is usually denoted as small letter f, like that, small letter f, y. I just have to differentiate this, right?
Yep.
That's exactly. So that means I just need to find a way how to go from here to here. Wait, no, sorry, from here to here, because we know what
Mm.
the PDF of f is in x, in terms
Yep.
of x. So we know the PDF of but the PDF of x right here. If you
Mm-hmm.
want to find the CDF, we would have to integrate, correct?
Yep.
Yeah. All right. So let's do that. So let's integrate. So right here, this is my first function and the second function. I changed the x into t for as a dummy variable. You know what dummy variable is, right?
Yeah. Yeah.
A dummy variable. So remember that the first function started from 0 to 1. But instead of writing 1, I use x to make it arbitrary. Same thing for the other one.
Mm.
It starts from 1, but I'll make the end an arbitrary x. Right. So we'll do this integral separately. That's why I put a small line here, just to show that it's separately done. And you can just integrate normally and put the boundaries. You should be getting these answers. So far, so good, right here.
Mm-hmm.
Right.
Yeah.
So that means, remember that this function occurs in 0 to 1, and this function occurs from 1 to 9. So that means
Mm.
our CDF in terms of x is right here. Agree?
Mm-hmm.
Right. Now that we have this, we can just replace our x with y squared, because that's what we're looking for, right? We already have fx here. I just need to change the x input into y squared so that I'll get this.
Mm-hmm.
Right. Right. All right. So now that we have this, remember to replace every single x, even in the interval, into y squared. Everything. Now from here you can simplify. You can simplify the boundaries also. So right here, the first change I did was that my f of x became fy. So this is a CDF in terms of y, which is what we're looking for. And our
Mm-hmm.
limits, our interval, sorry, I just took the square. No, the square root. So square root of 0 to 1 is just 0 to 1.
Mm.
While 1 to 9 is just 1 to 3. Agree here? Everything is okay?
Mm-hmm.
Right.
Yep.
So we can continue. So so we can continue by, since we know what fy is, we want to find the PDF of y. We just have to differentiate this in y. Correct? So you just have to take dy this.
Mm.
Agree? Right. So when we do that, we can just change the capital letter F into the small letter f, and everything here is already differentiated in y with respect to y, and this should be your final answer. So remember that the interval stays the same, but one thing is, don't forget to write the 0 otherwise. It means that the value is 0 for anywhere except for these places. Right. So that's your final answer. Though there is a small shortcut to make it more general. So note, for y is equal to a function of x, the PDF of y is just the PDF of f in terms of x.
Devan, your voice is cutting out.
Oh, sorry. Is it still cutting out? Is it still test?
Devan? Yeah, it's
Yes.
cutting
Hello.
out.
Hello.
It's still cutting out.
Be right back.
All right, we'll be back shortly.
Back, guys.
Devan?
Yes. Can you hear me?
Okay, yeah, you're fine.
Right. So as I was saying before, is that there's just a small shortcut. Is that if you're given y as a function of x right here, to find the PDF of y, you just need to have the PDF of x. Then you put the inverse of the function. So right here is g inverse of y, while taking the derivative of g inverse of y. No, this is just a bit more advanced. You don't really have to know this, but just a little shortcut for you to know. Right. So that's your answer, and that's it for this question. Anything you want to add, Yugan?
Uh, yeah, when I was learning this topic, I didn't get such a like step by step way how to do it. But yeah, thanks for laying it out. It
Yeah,
was really
man.
easy to follow everything. Yeah, like I used to think it was like quite hard because I did a much more like complicated way, but
Mm,
this is it's actually quite simple.
you're welcome, man. See, it's not that hard once you know it. All right, so let's
Yeah.
go for the next one. Oh my god, the paragraph's quite long. A company has two different machines, X and Y, each of which fills empty cups with coffee. The manager is investigating with volumes of coffee X and Y, small X and Y at least, measured in appropriate units, in the cups filled by machines X and Y respectively. She chooses a random sample of 50 cups filled by machine X and a random sample of 40 cups filled by machine Y. The volumes are summarized as follows. So we have the information right here. Now the manager claims that there is no difference between the mean volume of coffee in cups filled by machine X and the mean volume of coffee in cups filled by machine Y. So we have to test the manager's claim at 10% significant level. Of course we can do that.
Mm-hmm.
But first, don't forget to write our hypothesis. So it says that our hypothesis is that the means are equal of X and Y. In other words, if you
Mm-hmm.
take, well, I can also write this as mean of X is equal to mean of Y, but I just made it to the other side. So we have mean of X minus mean of Y has to be equal to 0 if they are equal, correct?
Mm-hmm.
If they're not equal, then they're not equal to 0. So
Mm.
yeah, that's your null and alternative. Now we're given so many information, and in these kinds of questions, you see that we have 50 and 40 samples. That means we have to use the normal distribution, correct?
Mm.
Now, if you want to use the normal distribution, you would need to know the mean and also the standard deviation or variance, correct? That's what
Mm-hmm.
we need to know. So let's find that with the information we're given. So let's start with our machine X first. So our machine X has 50 samples, and the sum of its X values is 15.2. If you want to find the mean, then it's basically just the sum of the X divided by 50, correct?
Mm-hmm.
That's what
Yep.
the mean technically means. The sum of the X values divided by the number of samples. So in this case, our answer is 0.304. Now
Mm.
the estimate for our variance, our S square. So the formula is, I'll show you here. It's in the formula sheet. I'll be there. Right. So it's just right here. Agree again? Can you see?
Mm-hmm.
Right. So
Yeah,
basically
I can see.
our sample minus one, times the sum of each data squared of each sample squared minus the
Mm-hmm.
sum of our x values squared over n. So in our
Mm.
case, since we have 50, we have 1 over 49 right here. And our sum of x squares is basically our 5.1 right here. We're given. So you don't have to find it by your own. So we have 5.1 minus our sum of x, that goes here. And don't forget to square it and divide by 50, our n. So once
Mm.
you have this, you can just, of course, you have to put in your calculator. You should get this number. Same thing for our y. Don't forget, we also have to do our y. So our y is 40 instead, and the mean is just 0.335. Same process for finding finding the variance. So we have 40 minus 1 is 1 over 39. 4.8 is the sum of y squares. Don't forget to put the sum of y here and square it. Divide by the total
Mm.
number of samples, which is 40. So you have these two variances right here. And yeah, congrats if you get them. Right. So the hard part is the test statistic. You have to memorize the test statistic right here. This is our test statistic.
Mm-hmm.
Looks scary, right? Right. So that means, so we have our x bar minus y bar, which is what we found before. X bar and y bar is our sample mean, while our mu of x and mu of y is our assumed mean, our
Mm.
hypothesized mean from here.
Mm.
So since we assume that the means are the same, or in other words, mu of x minus mu of y is 0, that means this part is 0, right?
Mm-hmm.
This part is 0. Our mu x minus mu y is just 0.
Yeah,
So
yeah.
we can completely disregard that. But the bottom part here
Mm-hmm.
is a scary one. It's the square root of the variance divided by the sample and added with another one right here.
Mm.
Right. So let's do that. So we can just put all the values that we know in. So we have 0.304, which is our x bar. This is our y bar. And this is our s square, our variance in x. Sample the number of sample in x. This is for y and also for y. Same thing
Mm-hmm.
basically. And once you compute this, you should be getting negative 1.55988, and so on if you have a better calculator. That's our so in other words, this is our test statistic.
Mm.
Now here's the thing: you get a negative, you don't really have to write the negative.
Mm.
That's why I put a cross here. You don't really have to care because first thing, it's two-tailed. It doesn't care if it's negative or positive. It's two-tailed. That's why. Because if it's two-tailed, it
Mm.
cares about in the normal distribution. It's like at the left tail and the right tail. So if you got a negative, you can just remove it. Now our critical value, of course, since this is we can assume normal distribution because the sample is quite a lot, 50 and 40. So remember that this is a two-tail test, and it's computed at 10% significance level. So let's try to find where that is. So we have, oh sorry, so when you want to look for critical values, it's always at the bottom of the page, right here.
Mm-hmm.
So here's the thing: since it's two-tailed, we have to divide our 10% divided by 2. So that means it's 5%, correct? So 5% we
Yep.
have to use 0.95. That means our
Yeah.
critical value is just 1.645, which is what I've written here. Agree?
Mm-hmm.
Right. So as you can see here, our test statistic is less than our critical value. That means we do not reject our null hypothesis. We accept it. And don't forget to write your conclusion. That means that their means are equal. Well, you can write a better conclusion than this. I got lazy here. Sorry. All right. So yeah, that's it for this question. Anything you want
Yeah.
to add, Ethan? Am I lagging? Hello?
That formula you gave at the top, is that hello, Devan?
Yeah, I can hear you.
Yeah,
It's
that
just there's a
formula you
small
gave at the
delay.
top, the test statistic, is that in the formula booklet?
No, it's not at all. If you see the further, probably you're only given one.
Okay. Well, then
You're only give. These are
wow,
this is
that
the only
is
thing they
not
give.
much. Um,
So do your best in
hi.
memorizing the test
I mean,
statistic.
okay, then yeah, that's something you guys have to remember.
And this is not the only test statistic in further stats. There will be more. Trust me, there will be more.
Mm,
Right, and this is just one of them.
all right.
One of the complicated ones. Right, so let's go for the next question. Sorry, I didn't use this page even. But okay, so let's
That's
go for number 5. A large number of children are competing in a throwing competition. The distances in meters thrown by a sample of 8 children are as follows. So these are the distances. Quite far, huh? 25 meters, so far. Assuming that the
mm,
distances are normally distributed, test at a 5% significance level whether the population mean distance thrown is more than 22 meters. Right. So here's the thing. They say that we assume that their distances are normally distributed, but they only give us 8 samples, which is technically not enough for normal distribution. That means we have to use our t distribution because t
mm-hmm,
distribution gives us the possibility to play with
mm,
small number of samples. In this case, it's 8. Right.
mm-hmm,
So let's write our hypothesis again. That our null hypothesis is that our mean is 22. Well, our alternative, it's greater than 22. And remember, it's 5% significance level. And because it's just greater, this is just a one-tailed
Mm-hmm.
test. All right.
Mm.
So let's put all. So we know that we have 8 samples. Now we have to compute our sum of x and x squares
Pop up table.
manually. Oh, it's okay. Right. So we have to compute it manually. So if you add all of
Mm-hmm.
these, and if you add all of these squared, each of them, you should get these numbers. Now, what can you do with that numbers? Of course, you want to look for the mean, for the sample mean, which is 22.95, and
Mm.
their variance from the same method as I mentioned before, which is just like this. And you should get the variance is just 5.06571. Right.
Mm-hmm.
Now we know that we can finally use our test statistic. So for this test, our test statistic is this one. So you have x bar minus mu. Well, in
Mm.
this case, our mu is just 22. Our standard deviation. Remember, I didn't write a s square here. That's what they give in the textbook actually, s over square root of n. But
Mm.
what you can do is that you put a square root and put a square here, because it's just the same thing, right?
Mm.
Right.
Mm-hmm.
So let's do that. Our x bar is 22.95, and our mu is 22. Now, instead of writing it this way, I combine the whole thing as a square root so that I have an s square here. But because we know what s squared is, which is this one, and divide by the number of sample. So far so good? You good?
Mm-hmm.
Right.
Yep.
So when you compute that, you should get 1.19 dot dot dot.
Mm.
Okay, so that's your test statistic. So after you find your test statistic, always remember that you have to find your critical value. When you play with hypothesis testing, it's always test statistic and critical value. They're best friends always. So
Mm.
right here, since the number of sample is really low, like 8, and it's a one-tailed test, and in 5%, that means we have to look for 0. All right, it's in right here. That means we have to look for 0.95. Oh, I forgot to mention, we have a degrees of freedom here. So how do you compute the degrees of freedom? Do you know how, Yugen?
Yeah, it's just your sample number minus one.
Exactly. So right here we have 8. So our sample number is 8. So we just minus 1. It's just 7. That means we look for 7 and 0.95. In this case, it's 1.895. Agree?
Mm.
Right. So we
Yep.
have that as our critical value. Now we can make our conclusion. So you see that our test statistic is surely less than our critical value. That means we don't reject our null hypothesis. We have to accept it, and we have to write our conclusion. The mean is not more than 22 meters.
Mm.
Right. All right. So that's for letter A. So let's go for letter B. Find a 95% confidence interval for the population mean distance drawn. So there's a formula for this. Since we're using t distribution, we also have to use our
Mm.
critical value in terms of t, and t distribution at least. So here's the formula. So this is our sample mean that you got before. This is the t value. But in this case, it's 95%. Wait, sorry, not 95%. Sorry. It should be 97.5%. I'll tell you why later.
Mm.
This is our t, and our s over square root of n, or just the whole thing. Then you put a square there. Same thing. Right. So the reason why it's 97.5% is because you're taking two values here. This is an interval where you have a plus minus.
Mm.
So that means you have to take the two-tailed version of this. So we can find that, of course. We have 0.975, and our degrees of freedom is 7. That means the t value is 2.365. Agree?
Mm.
Right.
Yep.
So once you have that, just plug everything in. We have our x bar as this, our t value is 2.365, and our s over square root of n is just this whole thing. Right.
Mm-hmm.
And then you just have to compute when it's at plus and minus, just like how you do quadratic equation. You find when it's plus and minus. So same thing. When it's minus, you get 21.1. While when it's positive, when you put a plus here, it's 24.8. So that means your
Mm.
interval is right here. Remember, you put a bracket. Is this the correct answer you get?
Yep, that is the correct answer.
All right. So easy 3 marks, just like that. Anything you want to add?
Mm. Uh, Not really. I had a lot of practice with t-test, so this was all fine for me. Just you have to remember all the formulas along with all
Yes.
the other formulas you have to remember, so that
Yes, you
makes it
have
a
to
bit
remember.
harder for some of us.
But it's kind of intuitive. Like you can see that this is the
Yeah.
middle and this is the left and right, right?
Mm-mm.
If you think about it, this is the mean that you got becomes the middle, and this is the how far you should go
Yeah,
left
yeah.
and right, like that. Anyways,
Mm-mm.
that's it for this question. Let's go for the next one. Probability generating function. You're also taught a generating function in when you take actual science. So if you
Mm.
learn this, it's really useful. Right. So a bag
Oh,
contains
okay.
four. Yeah, a bag contains 4 red balls and 6 blue balls. Rasa selects 2 balls at random without replacement. That means you don't put the ball back in from the bag. The number of red balls selected by Rasa is denoted by x. Find the probability generating function of x. So an easy way to do this is that you would make a probability distribution table first. So right here, we can make a probability distribution
Mm.
table. So of course, you since you only get 2 times, the maximum number of red balls
Devan,
you
the
can take is
stream
2.
froze.
Oh,
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 okay, it's
sorry.
back. It's back.
Is it okay now? Is it okay now, Yugen?
It's back. Your camera's frozen though.
Okay, wait. Let me restart for a while.
No, okay. We'll be back shortly.
Well, I wonder what happened to my Wi-Fi today.
Yeah, of all days. Welcome back.
Hey, thank you. All right. So as I
All
was
right.
saying, is that I think if you want to do these kind of questions, it's best that you make a probability distribution table. So at first, of course, you don't know what the values of these are, but you know what the x values are. It's 0, 1, 2, because there's a possibility
Mm.
you don't get any red balls, and the maximum number of red balls you can take is 2. Agree?
Mm-hmm.
Right. So let's find when x is 0. X is 0 is just since there are 6 red balls. Wait, so wait, sorry. Wait, let me check again. Oh, sorry. There are 6 blue balls, and there are 10 balls in total. So it's 6/10. But the next pick, you don't get a red ball. You got a blue ball. But since you don't replace, that means the total
Mm.
number of balls decreased by 1, and also the blue ball. So it's 5/9. And I hope you get
Mm-hmm.
this. This is just the probability from statistics 1. Same thing when you do 1. X is equal to 1 when you get only 1 red ball.
Mm-hmm.
But in this case, it's either you get the red ball first or the red ball the second time. That's why you have to add these 2 probabilities. And same thing
Mm-hmm.
for 2 balls. So you should get these numbers. Now, how do you make the generating function? So the generating function, all right. So as you can see here, you see that there's a
Mm-hmm.
power, right, in the t here.
Oh yeah.
This is just 2, this is 1, and this is technically t power 0.
Yeah.
So the
T0.
power of t represents the x value, while the
Mm-hmm.
coefficient of t is the probability. So in this case, our our first term will be t0, t power 0, and its coefficient
Mm-hmm.
is 1/3. Next one, when t power 1, it has a coefficient of 8/15. And same thing for the last one. I hope you get that.
Yeah, yeah.
Right. So and that's it. That's your GXT, prob your PGF. Yeah, PGF in X. And don't forget to box it. For next one, Rasa also tosses 2 coins. Why is she making things so hard? One coin is biased so that the probability of a head is 2/3. Even the coin is biased. The other coin is biased so that the probability of a head is P. The
Mm-hmm.
probability generating function of Y, the number of heads obtained by Rasa, is GYT. The coefficient
Mm-hmm.
of T and GYT is 7/12. Right. So she has 2 coins. Both of them are biased. She's making our life hard, and we have to look for what. P is first. Or else we cannot find what GYT is, correct?
Mm.
Right, so we have to look for P first. So when they say the coefficient of T is 7/12, what does that mean, Yugen?
So that means because you're flipping two coins, when you
Mm-hmm.
multiply the probability of the first one getting the hit and the second one is not, plus vice versa, you would get 7/12.
Exactly. So right here, let's do that. So that means this is our. Wait, sorry, I forgot the. All right. So this is when the first coin is ahead, the second coin is not ahead. When the first coin is
Mm.
it's not ahead, and the second coin is ahead. Correct.
Mm-hmm.
Right. So you have this equation. Okay, of course, you can just solve it. I'm pretty sure you know how to do it, and you should
Oh
get
yeah.
that to 1/4. Right. So it's good. Now you know that P is 1/4. Now you can go ahead and get the table, the distribution table. You don't have to compute when it's 1 because they already give you. You just have to compute when 0 and 2. So this is when they're both of them are not heads. So it's 1/3
Mm.
times 3/4 is just 1/4. And same thing for when both are heads. That means it's 2/3 times 1/4. That's 1/6. Right. So when you get this, it's already easy. Just make the PGF in Y, and that's it.
Mm-hmm.
Easy marks.
Mm.
Right. So anything you want to add here?
Uh, no, for both of these, it's pretty straightforward stuff. For B, yet to think a little bit, but I don't think it's much for anyone doing this law.
Yeah. All right. Right. Next question. We have the random variable z is the sum of the number of red balls selected and the number of heads obtained by Rasa. Right. So let's say if you get 2 red balls and you get 2 heads, then it's just 4, like that.
Mm.
So the next one, find the probability generating function of z, expressing your answer as a polynomial. Why? Why would you do that? Whatever, we'll do it. So if you want to look for the PGF in z, remember that z is the sum of x plus y. So I can rewrite z as x plus y. Agree?
Mm-hmm.
Right. So there's a rule here. Yeah, a rule, I guess, that if you have g of x plus y, as long as they're independent, you can split. You can like split this, and you have two separate PGFs in their respective
Mm-hmm.
variable. So if we have g of x plus y, it's the same as g of x, gx times gy in this case, right?
Mm.
But we know what gxt and gyt is, and we just have to substitute them in.
Mm.
And yes, I know you have to multiply them one by one. Yep. So good luck on doing that. I'm not going to do that here because we barely have any space. And I'm going to explain you how.
I should have given you space for all that.
Basically, yes, you really have to expand this, and you should
Mm.
simplify it. And this should be your final answer, right? So this should be your final. That means GZT is this polynomial right here. It's a crazy looking one.
Mm-hmm.
Right. So it's not so easy marks, but it's just gonna be so tiring. But good luck. Right. So that's your answer for the letter C. Now for letter D, use the probability generating function of z to find expectation of z. Do you know how to find expectation of z?
From probability generating, no, I don't think so.
No, you don't know. There is, if you don't know how, there is in the formula sheet. Luckily, it's in the formula
Oh,
sheet.
okay.
Yes. So when you have a PGF, you just have to differentiate it, and you put 1 in here, and that's your
Ah,
expectation. It's so cool, right? You just have to differentiate and put 1. It's so nice.
yeah.
There's also
Hang
for
on.
various.
Before that, we have a comment.
Oh, yes.
Let's see. Hey guys, I have my prob and stat one exam in the coming months. It would be great if you get some. Okay. Well, this series just covers the math past year papers from May June exam this year for all the math. So if you have a suggestion or anything, you can send it to our math AMA and we will take a look.
And also, we've already done a statistics 1 paper last time, so you can check that out.
Yeah. So If you're referring to AS stats, you can go check out our video on our channel.
All right.
All right.
So thank you for that. Let's continue.
Mm-hmm.
So if you forget how to find expectation, you can just check it here. Same thing for variance. You can just check it here. You're lucky you get this. Right.
Mm.
So so of course let's do that. Why not? So since our expectation of z is just g dash of z when it's 1, of course we have to differentiate first. We have to differentiate this whole thing. So let's do that. When we differentiate this, we should be getting this. I don't think I should explain how to differentiate polynomials. That's a AS level maths. And
Mm-hmm.
once you have your derivative, that's when you finally put t is equal to 1. And when you put t is equal to 1, you should be getting this result. So the result is just 103 over 60. So that means our expectation of z is just about 1.72. Is this the correct answer?
Mm-hmm. That is the
All right.
correct answer.
So box the answer, and we're done with the paper. This is the final question already.
Mm-hmm.
Right.
Uh,
So that's it for statistics paper. What do you think, Yugen? What do you think of the paper?
well, some of the questions I couldn't do because I haven't learned them, but the questions that I could, they were fine. Thankfully,
Okay.
this one it was in the formula sheet. Uh, Also, for this particular question, it is useful to remember the rule on top, or else you'd have to make like the table for everything and do up to the
Oh my
power of
God!
four,
Please don't.
which can be
Oh my God!
which can be a
No.
lot more tedious than this simple polynomial expansion.
It's just 3 marks. Don't draw your tables, please. Oh my God!
Yeah, don't waste all that effort.
Oh my
Uh,
God!
Also, if you were wondering, for that polynomial, you could factor out 1 over 180. That's what the
Oh,
mark scheme does, but it's not like necessary.
yep. You can factor out 1 over 180 here, and you have a whole. All of this will be integers.
Yeah, that is quite coincidental, but okay.
Yeah, that's okay. That's okay. Okay, so we're done with the paper, right?
All right. Um, and yeah, that's it for today. I hoped all of you enjoyed the session and learned something valuable. Thank you, Devon, for taking your time to do this session. Please follow our social media shown on the next screen, and we will see you guys soon for our AMA session next Friday. If you guys have any questions you would like to ask, please join our Discord community where you will be able to ask questions in our hashtag MathAMA channel that we'll answer next week. David, anything to add?
Yeah, that's it. Honestly, when I remember when you do further statistics, is that there are so many test statistics, and you have to memorize them. They just don't give you in the formula sheet. They're that cruel.
Mm-hmm. All
Right.
right.
So
Thank you, everyone, and good night.
all right. Good night, everyone. We'll see you next Friday. Goodbye.